So in this example, we are going to be determining the modulus, and we have these 4 problems here. In order to do that, we are going to be using the division algorithm. And don't forget the division algorithm says A is going to be equal to Q, which is our quotient, times B plus our remainder. Now don't forget what the division algorithm also says is that our remainder has got to be greater than or equal to 0, but less than B. Now B for here is our modulus, even though it has it as N here for modulus. That's what B is going to be here. So for the first one here, for 193 is congruent to 4 mod N. We're going to write it in terms of the division algorithm. So I'm going to go 193. That's going to be equal to Q times B. That's our quotient and our modulus, plus our remainder. And our remainder is 4. Then we'll use a little bit of algebra. I'll subtract 4 from either side. So this will give us 189 is equal to Q times B. Now to help determine our modulus, I'm going to do prime factorization on 189. So if we have 189, that's 3 times 63. This is not prime, so we continue. It's 3 times 21 and 3 times 7. So any one of these factors or a combination of these factors can be our modulus, but we want the smallest modulus. When we have the smallest modulus, that ensures that our division was complete. So we're going to use this part right here to help us find that. So since our remainder is 4, 4 is greater than or equal to 0, but it's got to be less than our modulus. So our modulus can't be 3 because 3 is not less than 4. But it could be 9. 3 times 3 will work. But is that the smallest one? No, 7 is. So our modulus has got to be 7. So we can say that 193 is congruent to 4 mod 7. So we have 7. Let's try B. Same idea, 1,277. I'm going to write this in terms of the division algorithm. That's going to be equal to Q times B plus 3. Using algebra, I'll subtract 3 from either side. That's 1,274. It's going to be equal to Q times B. We'll use prime factorization, 1,274. That's 2 times 637. And 7 times 91. And I think we got them all. 91 is a prime number. So again, our remainder 3 is greater than or equal to 0, but it's got to be less than our modulus. And we want the smallest modulus possible. Well, it can't be 2 because 2 is not less than 3, so it's got to be 7. And there we go. 7. Let's try C. 548. Write it in terms of the division algorithm. That should be equal to Q times B plus the remainder of 14. Using algebra, we'll subtract 14 from either side. This is going to be 534. That's equal to Q times B. Use our prime factorization. It's going to be 2 times 267. 3 times 89, and 89 is prime, so we can stop. So our remainder is 14. That's greater than or equal to 0, but it's got to be less than the modulus. And the modulus for here can't be 2, it can't be 3, and it can't be 6, because none of those are smaller than 14, so it's got to be 89. So we have 89. Now we can check this, and maybe every now and then you should. So that means if I have 548 is congruent to 14, that must mean that 548 modulo 89 has got to give us 14. So we'll do that. 548, divide that by 89, gives me a quotient of 6. 6 times 89 gives me 534. 534 will give us a remainder of 14. So it works. Let's try D. Again, writing it in terms of the division algorithm, negative 229. That's going to be equal to Q times B plus the remainder of 5. With our algebra, subtract 5 from either side. This gives us negative 234. That's going to be equal to Q times B. Now we only want to do the prime factorization on the positive result, so we'll do 234. That's 2 times 117. 3 times 39. 3 times 13. And I think we are done. Again, our remainder is 5. So that's greater than or equal to 0, but it's got to be less than our modulus, and we want our modulus to be as small as possible. It can't be 3, and it can't be 2. 13 isn't the smallest, so it could be 3 times 2, which is 6. So here we have 6. And again, we can check it. We could say negative 229 mod 6 should equal to 5. So we'll try it. Negative 229. Divide that by 6. Don't forget, we always round our quotient down. So I'm going to round it down to negative 39 times 6 gives us negative 234. So that gives us a difference of 5, a remainder of 5. So it works. And there we go.